What you see here is a variety of equipment that you're going to use in the electricity series of experiments. And we're going to look at these things one at a time. This is a generator. You use this to generate voltage and to create currents. Now this doesn't generate very high voltage. If you crank it really, really fast, you might generate enough voltage that you could feel a little bit of tingle if you put it across your tongue or something, but I don't recommend that. Now, crank the handle. It creates what we call a voltage, and we'll see what that means later. We can connect these leads to various things. Right now these leads are just hanging out in thin air, and I can crank with these leads here connected by thin air. Alternatively, I can connect the leads together. Now you might hear a little difference in the sound and see a little difference in the rate at which I crank this thing. We can attach these leads to various things and feel the difference. There is a difference in how it feels to crank the device. Crank it. Okay, we've got it connected here across a nail. Just a regular nail. We can just let that dangle, and we can crank, and we can see how it feels to crank across a nail. Try not to knock everything off the table in the process. Here's a piece of a Dr. Pepper can. You can see some of the writing on it. We can connect this thing across a piece of a Dr. Pepper can and see what that feels like. Okay. We could connect it. Let's see, I thought I had a piece of aluminum foil here. I don't. If we had one, we could connect across the aluminum foil. We can connect across the rubber band that I have here. And we can crank. There's a paper clip hanging from the rubber band. Let's put one end on the rubber band and one end on the paper clip and see what happens. Now, I'm not going to tell you what happens. I want you to experience what happens. But okay, here we go. What if we put both ends across the paper clip? What's going to happen now? Okay, well, something happens there. If I wasn't afraid of tipping it over, I've got a glass full or styrofoam cup full of water. I could clip this thing onto the cup. We could clip it onto a glass. We could clip it onto a metal mug. I could even take these leads and drop them in the water. This is not a high voltage thing. We're not going to get any kind of a dangerous voltage, and see what happens in the water. So you see, you get the principle. We can put this across various materials. I can hold it with my fingers, one end on each finger, and crank. Don't feel much of anything. I'd start cranking slowly if I did that. If you get uncomfortable, you might want to stop. Okay, now what I'm going to do is I'm going to clip these leads across a light bulb. Now let's explain how I just did that. Let's put maybe this dark background up here so hopefully you can see just a little better. But each light bulb is in a holder, screwed into a holder in this piece of wood here. And we've got a tab here and a tab here. Now if we put one lead on one tab and the other lead on the other tab and crank, I think you can see the light bulb going on. Now we don't want to crank really, really fast because we don't want to burn this light bulb out. It isn't really that hard to crank this thing fast enough to burn the light bulb out. But when we do crank with this light bulb, we get some force. Okay, we can feel some, we have to exert a force, more force than we would if we didn't have the light bulb. That's because, of course, the light here is using energy, requiring energy, giving off energy, and we have to put enough energy in to light the bulb, and that's what we're doing by cranking the crank here, by cranking the generator. And you want to think about those energy relationships. Now I can take one of these wire leads here. I've got several wire leads with alligator clips in the end. You just open them up and close them. You see they clamp onto things. Don't clamp them onto your finger because it'll probably hurt. But I can connect these things so that, well, let's see, it might be a little hard to see exactly how I've connected this, but I've got one lead from the generator on this tab. Then I'm connecting the two tabs here, and then another lead leading back to the generator. So current can flow through here, through the first bulb, through this wire, then come back to this lead and back through the generator. And when I do that, I see that I can crank them both. One of the bulbs lights more than the other in this case, and that has to do with some of the numbers that are marked on the bulbs, and you can see how that works. We might try reversing the lead here. I'm not going to actually crank it. I think you ought to try this and find out. Now that I've reversed the lead so that the current goes through this bulb in the opposite direction, is that going to affect the way the bulbs light? Or if I reverse the two leads from the generator? So you might want to experiment around with that a little bit and just see what happens in various circumstances. However, what I really want to do here is take the leads and put them back across the first bulb again. Now the series that you just saw, where the current goes first through one bulb and then through the lead and into the other bulb and then back through the generator, is called a series circuit, where the bulbs go in series. First the current goes through one bulb, then through the other. Again, that's called series. Now I'm going to do what I call a parallel circuit. Again, here's the first bulb is lighting. Then what I want to do is I want to give the current an alternative path. Okay, see, it has a path where it can come into this lead, through the bulb, and back through this lead, and then travel back through the generator. I'm going to give it an alternative. I'm going to put one alligator clip here, like this, from this lead over to this bulb, and the other, another lead from this generator lead over to the other tab of the bulb. And now the current comes out of the generator through one of the generator leads, through this generator lead. Then it has a choice of going through this bulb or traveling through this red wire here and through this bulb and then back to the other lead of the generator. So there are two paths from one lead of the generator to the other. Two paths leading back through the generator. One path through this bulb and one path through this bulb. And I can crank the system, and I'm going to let you see what happens there and what it feels like. Now we're paying attention to things like how fast do we have to crank and how hard do we have to crank. And those things are going to relate to some very important concepts.